Hey everybody, sorry I'm late. Oh gosh, I have got my head crammed so far up my backside. I am smelling the snacks I had last night. Goodness me. Here we go. I'm gonna put my thing on the what's it and put the what's it up here. Turn on the robot. Is it active? It's active. Here we go. Holy cow. All right, so I did a bunch of stuff in between this morning and now with the diagrams that I was banging on. And I'll pop out the chat. We'll bring it over here. And I'll put this here. Activity feed. And I'll just put this in the background. Here's Streamlabs. And I'll do this. And I'll do this. And let's go to main screen focus. Boop. And yeah, I can go ahead and use this view for what we're going to talk about. So I've got my static system architecture. Here we are. And we got this updated this morning nicely. And you can see that the AI subsystem is sort of off in this gray stuff over here. And it's even under different project naming conventions. And there's a big reason for that. I want to make my face bigger for these talks. Here we are. Hey, I'm way larger, way bigger. Oh no, don't move it. I think I'm too big. There, that's better. And I'm going to zoom in here a little bit on this view. So here is our sort of large view of the architecture. Now, up here you see our Blazor client. It calls into that API project. And currently, the way I've got this built out, all of this is in proc. Like all of this stuff, whoops, is running in the same process. And that's fine. It's a monolithic deployment, but rather than have a bunch of stuff crammed into a Walmart bag type monolith, I've got uh, a nice box, and all of the pieces are nicely stacked in there. I don't know if you've ever played the really fancy, expensive board game Dark Tower, but the way it's distributed, it's like a tabletop role playing board game type thing, and there's a million pieces and all kinds of complicated stuff, and the tower itself connects to the iPad, and the iPad acts as the dungeon master, and it actually comes with instructions for taking things out of the box and putting them back in when you're done playing. Um, and that's sort of the way I'm trying to construct the monolith of this application. So all of these things, all of these little boxes are running in a single compute process right now. However, the AI subsystem, I could just as easily come into the workload provider, comment out the code that invokes the AI, or alter it to say, sorry, AI is not available, and just delete that subsystem altogether without really too much pain at all. Or if I discover that the AI subsystem needs to live in its own process when we deploy this, I can easily pull those components out of the main application, wrap them in their own API, and then create an API proxy up here in the workload provider and just make HTTP calls to it or brokered messaging calls or whatever. I would probably do HTTP calls too, and then broker the responses back through some sort of queuing system. But that's a level of complication that is higher than I want to take on right now. I've done it before. It's a lot of work. It pays off when it's needed, but if you don't need it, don't make the investment. It's best to have that as a plan for when you do need to scale out or start fracturing things. Make sure that the way your components are written uh, doesn't prevent you from being able to pull things out of your main process and put them into a side process later on if it's determined you need to. And then, of course, we've got all of our NPC related workloads in here, all of the townsfolk related stuff like creating a new one, picking the attributes randomly, list, save, eventually edit and filter, all that stuff, all there in the townsfolk manager. And these components, like the rule set access, we can add new rules to that or new species, backgrounds, vocations, eventually character classes, eventually ability scores, eventually skills and playtime abilities, perhaps. Maybe eventually we create a map manager, a game session manager, etc., 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 that just reuses elements of these components. If I create a character tracker, I would create player character access, um, creature access, and so on down the line. But another reason I've got the AI subsystem over here. Hey, Frightful, how are you? Another reason I've got this AI subsystem sort of fractured out over here is because AI technology itself moves very, very quickly. What was popular? Yes, this is a Perry the Platypus t-shirt, Mr. Frightful. I am a big fan. I'm also a big fan of Avatar The Last Airbender. I'm going to have to get that one out tomorrow. So AI, the technology behind or around AI moves very, very quickly. And the libraries that we use to communicate with those AI services also change very, very quickly, faster than the code in the rest of my system here. Now, I don't necessarily have to change my code every time those things change, unless, of course, a service that I'm using is being deprecated or the way I need to talk to that service is going to change significantly. And I've observed that that does happen a little bit faster than I necessarily want to be updating my main application. So that would be a reason to pull out the AI subsystem sooner than later into its own discrete service so that it can change at the same rate as the technology that it's managing for me. Now, how do we make sure that our nice little architecture here can be broken apart into discrete services? Well, for that, we got to get into a little bit of design details about the code level and how they work with each other. Now, if we were distributed, like fully distributed, like in a microservices model, we'd be talking a lot more about proxies than we have been so far. But I'm not really going to get into those yet. So let's talk briefly about some design principles for this style of architecture that I'm doing. And let's just make a little rectangle. And I'm going to make this a different color. Where's the format? Edit style, edit data, edit connection points. You know what? Let's just bring up the sidebar. Here we go. And I'm going to make this green. All right. So we have, and I'm going to add some text. There's a better text thing for this. And it's, where's title? Here's title. Boop. Let's drop title on here. And let's say component A. Component A dot csproj. Just for laughs. We'll pretend we're living in a world where dotNet is the only thing and it's the only way to do stuff. I don't want to do that. Delete. I'm going to grab my text and that, and I'm going to group them. Group. Where's group? Here's group. It's right in front of my face. V. And we've got component B. And component A uses component B. All right. And in fact, I'm even going to twist this around so that it's vertical. Now, I'm going to redo that. And what in the name of God is that doing? Let's undo some stuff here. Here we go. Let's rotate it so that it's like so. Cool. So component A uses component B. And component B, whoops, uses component C. And we'll just connect this guy to that guy. I'm going to copy and paste. And they all have the concept of a person, maybe. No, they all have the concept of a thing. I want to scooch this down a little bit. Down we go. I'll pull this down like that so that we're a little bit better spaced out here. This guy, we're going to move you right up here. We're going to pull this, whoops. Oh, right there. And let's say the purpose of this system here is to manipulate things. Use case. Do stuff to things. And I'll return that guy orange. Yeah, come on, go orange for me. Not the text. Style. Orange. And this guy, I'm going to turn him that blue color. Cool. So component A is responsible for showing the things. and collecting the nature of the stuff we're going to do. Component B, let's call this component A. We'll call it the user interface. And then UI shows and collects information about the stuff and things, shows the things, lets us do stuff to the things. All right. And then over here, we've got our logic layer. And we'll copy and paste and put this storage. Stores the things in between sessions of doing stuff to them. Actually does the stuff to the things. All right. So in the user interface, there's attributes of things that the UI really only cares about, or only the UI cares about. Just like down here in storage, and let's change this to logic. Thing stuffer. No, wait, it's stuff doer. Stuff doer. This is thing storage. And thing shower. Okay. So the thing shower uses the stuff doer. The stuff doer, some of the stuff it does is store and retrieve the things. Now in the database, we have a storage model. And a mistake that I've made when I was a much more junior developer and much less mindful about making sure these components can be separable if needed and so on. Storage model. So like a thing in storage looks a certain way. And a thing in storage has attributes that only matter to the storage part of the system. All right. Now copy and paste this. And then we've got a formal name for this would be presentation model. And I'm going to have to make this element a little bigger. A thing, as it is shown on screen, has attributes that only matter to the user interface. Colors, font sizes, selection choices, etc. And then at the logic layer, or our, what a lot of people in the industry call a business model, a thing at this layer has attributes that are only relevant within the logic components of our application. And in fact, there may be subcomponents inside StuffDoer that only care about a small subset of the attributes of thing. So an example would be a customer. Well, a customer, there's a ton of attributes around the concept of a customer. A customer has identifying information, like, yes, I told you I'd wear it today, tomatoes. Tomatoes cannot be trusted yet. Was in the stream with me yesterday, hanging out, and we talked a little bit about our favorite animated shows, and he brought up Phineas and Ferb, and I said, hey, I have a Perry the Platypus t-shirt, and sure enough, it was at the top of the clean t-shirt drawer this morning, and I put it on. So what I'm talking about right now, tomatoes, is some detailed design matters in terms of how we ensure that if we build a system that's initially going to be deployed sort of as a monolith, much like this NPC helper thing that I'm doing, we're going to deploy it first off as like a single process web app of some sort, probably an Azure App Service type thing. And then later, when we identify the parts that need to be pulled out into discrete services, we can do so with minimal pain. Such as the AI subsystem, it's probably going to get pulled out into a discrete service before anything else does, more than likely. Because I don't anticipate seeing too many bottlenecks at the data access level yet, because those queries are dead simple. It's like select where primary key ID equals primary key parameter, insert, update, stuff like that. Nothing really complicated. That the Dice engine is pure C#. Yeah, man, lurk away. And our manager, of course, coordinates the work between the engine, access for resources, and so on. Eventually, I might pull this NPC manager out into its own, or the NPC manager and its dependencies out into its own service if I need to. I probably won't. And then, of course, I've got this API workload provider, which is sort of a back end for front end. It combines all of the use cases into end user tasks or end user workflows. And this is just a composition layer, nothing more than that. similar to a manager where it composes the capabilities of its inner components to provide use case implementations. The workload provider combines use case implementations into features, I guess, would be features or tasks that are made available through features, if you want to use that type of thing. So, how do we ensure that we're able to treat each of those boxes out in the static architecture as an independent thing? Like, I could go absolutely bananas and drop all of these things into containers, wrap an API around each one, and then just set up proxy classes and interfaces through like an SDK package or something like that that I'd have to create. And just like in my townsfolk manager, instead of having a direct project reference, I reference a NuGet package for the dice engine proxy and the rule set proxy and the NPC proxy, which would be responsible for making the HTTP call to that remote component. I'm not going to do that because that's a whole lot of extra plumbing code that I don't want to write right now. If I discover that I have to, then I'll write it, but I probably won't. So I am not going microservices first because that adds a whole lot of non-business functional complexity and a whole lot of extra code that isn't solving the actual real world problem that I want to solve. So what do we do to make sure that we don't corrupt our ability to pull these things apart? We let our presentation model understand but not own the business model. And we let our business model understand but not own the storage models. So I'm going to create some more text. I grab this, owns, and now I'm going to grab an arrow. I'm going to pull this guy up here. I'm just going to go underline or overline for now. And we'll move, stop trying to help. Goodness. I'm going to group these guys. Group. I'm going to copy and paste. Grab this fella. I'm going to grab this fella. Come on. Stop that. I feel like I'm playing a complicated video game that is not meant to be played by like a normal person. Not that I'm a normal person. Oh, cut it out. Because this is some goofy stuff, man. Here we go. Owns. Great. So the UI owns the presentation models. Logic layer owns the business models. Storage owns the storage models. And do we have a curved arrow? No, I don't think we do. That's okay. But I'm going to grab another directional connector. Just pull it out there. Do one of these. And I'm going to grab some text. Drop that up on, no, Jiminy Cricket. Stop that. Text. Move you up here. Changes this to understands. And these guys are going to get grouped. Copy. Oh, wait, no. Arrange, group. And now I'll copy. Paste, paste. Grab it. Stop. Do one of these. And I want to rotate the whole shebang like so. And I only needed 2 of those. Pull you down here. I'm going to undo and undo. Are you guys grouped or what? Arrange, group, there. Grab it, rotate it to 45. Pull this guy down here. There we go. So when the UI layer or the presentation layer wants to pass something or have the stuff doer do some stuff to the thing, it collects and packages up the data that is required to be able to do the stuff with the thing and adds it to a business and creates a business model and passes it into the logic layer. And the logic layer accepts that business model and does the things and then maybe stores it, which means it needs to translate its business model into one or more storage models and pass those out to the storage layer. And then if the storage layer sends anything back, it's going to send back those things as storage things. Our business model will convert the storage things into business things. And then it's going to pass those business things up to the presentation layer. And the presentation layer is going to take those business things, turn them into UI things or presentation things, and show them on the screen. And because we have each layer responsible for mapping from its local idiom to its dependency idioms, but no further, that means that we can take anything below our UI layer and do the Patrick Star thing where we say, what if we take the code from over here and put it all over here? And that gives us that portability. It also means that we can make changes internally to here or here or here. And if those changes don't affect any of the external contracts, then we've just limited the amount of code that we've got to alter to change the name on a button or change the way we're simulating random dice rolls. Or perhaps we realize that we have 7 choices and we don't have a 7-sided die, so we need to implement a card shuffler dealer type thing so that I can take the 7 choices and say, pick one of these random ones. And my card shuffler component does that. And we never skip layers. And our storage model or our storage layer will never call the logic layer. And it'll definitely never call the UI layer directly. And our UI layer must never, ever, ever call directly into storage. for a plethora of reasons. Um, the biggest one that really freaks me out when I see it happen is it usually means that we end up with things like connection strings out here in a publicly published application. And that to me screams a security hole big enough to fly a space shuttle through. I don't want the keys to my database living in any compute process that's exposed to the internet because it's only a matter of time before the bad guys figure out how to get to where those keys are stored. Now, with modern cloud architectures, yes, you've got Key Vault. In Azure, you've got other kinds of secret stores and so on. There are other ways to manage that information. But it still really just gives me the creeps whenever I see a web application that's got connection strings in its config. And yes, I am currently giving myself the creeps because I do have connection strings in the config for my Blazor application, but it's running locally. It's not published outside of my local area network. And even if somebody got root on my Wi-Fi network, all they're going to get is access to a table that contains some NPC data. So I'm not that worried. Um, One of the scariest pieces of advice that I ever received during my architecture training is always pretend the bad guys have root inside your inner network and build your software as if the bad guys have root on your LAN. And that's kind of why I've been gun shy about looking into things like Next.js or Node.js services. Because at least with Java and C Sharp, and I believe you can use uh, C transpiler on Python that turns your Python code into C code that you can then compile and make into basically a C executable. I think it's called Cython, Cython. I don't know how well it works across the Python ecosystem, but um, the idea of having my business logic or anything on the server side in a text file that is an end user editable that that's an editable script that anybody with root access can manage and maintain and make changes to, that gives me the creeps. I can't, from an enterprise development perspective, I cannot advocate for that. And that fear could well be born of ignorance. I'll own that. If it's actually possible to secure a JavaScript based server side service so that it's not modifiable by anybody without specific permissions, um, I could change my tune, but it doesn't mean that I'm going to switch to JavaScript because I don't like the programming models. So back to this. If we follow this simple design principle, and this is just uh, isolation, it's component isolation. I'm going to group this, arrange, group, and this is really just, uh, oh, come on, select something. Here we go. I'm going to move this down. And what do we call this principle? It's not single responsibility. Well, I suppose it is. But let's just do this. Move this down. Oh, come on, Rob. I'm going to use a rounded rectangle. And I want to go with a light green background with not white. White on light green is a Marquis de Sade level color choice. And can I edit text? No, I can't. I'm just going to have to bring text up here. Where the heck? Z. I'm going to drag that up into here. And I got to change this to black. Here it is. Apply text. And I'm going to want this slightly bigger. Let's go to a 14 point and we'll bold it. Favor. Building a system from independent components that each expose just enough information about themselves to be utilized by other components as dependencies. And let's do this, and I'm sure there's a better way of expressing this. It is best to, and this really just feels like I'm dictating from on high. It is best to construct components that provide specific capabilities with as small an integration surface as possible. Dependents are responsible for translating between there, and I'll fix this spelling, local idiom for a concept into their dependencies, conceptual idiom. Into their direct dependencies, conceptual idioms. That's better. Construct, design, and build components that provide specific capabilities with as small an integration surface as possible. Public idiom. AKA. There we go. Public. There. Yes, I like that. That is a decent statement. I can live with that. Now, let's get that guy selected. Pull him down. There. And why do we do this? It allows us to pull these components apart later or reassemble them later as needed or combine them in other ways that we haven't even thought of yet. Or perhaps the marketing guys want us to build a chatbot UI instead of a web-based or mobile app-based or screen-based. I have a form. It shows data. I edit the data. I push a button. It goes to the stuff doer. The stuff doer does stuff and stores it into thing storage. What if the marketing guys say, hey, we really want a chatbot that can do all of these things too? Oh, crap. Okay. So I still need the stuff doer and the thing storage, but I'm going to have to throw a chatbot instead of the thing shower. So I'm going to have to make a thing chatter. So I will grab my stuff doer project and my thing storage project that maybe by this time are actually NuGet packages and import those into my thing chatter project and write the code to create the chat-based UI or the chatbot-based UI or whatever. And then when I have to change stuff doer, yeah, I have to update both applications, but I don't have to write the code twice. Or perhaps, the marketing guys say, hey, we need a chatbot to go along with our thing shower. We need a thing chatter. And so you say, okay, so we'll break thing shower out into a discrete web application. We'll put stuff doer and thing storage behind an API, and then we'll create thing chatter and just call the same API as thing shower. And that gives us that business agility that we're after. Just like over here with my system static architecture, I was talking about this thing with my wife. She's one of my D&D players, and she's not as bad as some people that I've played with. As a matter of fact, she's a great deal better than a lot of the many of the other players I've played with over many, many years of playing D&D and running D&D games. She's not the first one to say, so what's the merchant's name? But she'll write it down if I make one up on the fly. And she's the one that will remember what that merchant's name was next time. But I was talking with her about this concept that I have. And I was like, the way I've built this, I could very, very easily just put together a dice roller screen and add a new menu item that says, give me a dice roller. And now it's not going to make pretty graphical dice bouncing around your phone screen or anything like that, but you'll be able to say, give me 2d20 plus minus 5, or give me 1d20 with advantage and stuff like that, and just have that at your fingertips while you're doing other stuff in the app. And it would be a very simple matter for me to create that dice roller component or that dice, the roll manager, ROLL manager, expose some workflow or expose that use case through some through some operation contracts and incorporate that into my Game Tools API workload provider. build a screen, done. All because I'm not sharing all of these bloody contracts throughout the whole system. So that's where I wanted to go with our detailed system design principles. This is the number one thing. Yes, you end up with a lot of mapping code and a lot of code that feels like you're doing the same, feels like you're violating don't repeat yourself. But I promise you, as you're iterating across your vertical slice, across, or as you're iterating up and down from UI to storage, or UI to logic to storage and back again, you're going to find that the business model's structure and the properties that live on the business model, you might start off with the UI and the business and the storage model all looking very, very much the same, but your storage model is going to drift. Your presentation model is definitely going to drift. And over time, they're going to stop looking so closely to each other. Now, you're still going to be dealing with the same conceptual idioms, or the same local conceptual idioms, but the structure of those objects and classes will diverge over time. It's an inevitability. And when the inner business model structure changes, the only thing that I might have to change, unless it's like a major change to the nature of this workflow and the data that we're working on, the only thing that I might have to change is that public contract and the translation code. And that's it. The mapping code. And this is a hugely powerful concept. And I know people are going to say that's over engineering and that's way more than you need to do and so on. And for a proof of concept, when you're just trying to prove that something's possible, absolutely, it's overkill. To that, I say I have never seen a scenario where I've been asked to prove that something is possible. And so I go away and I write something quick and dirty and I go back to my boss and say, hey, look, it's possible. Watch this. And he's like, great. Can we ship it next week? Absolutely not. I'm going to need 6 months between now and having something where I can actually put this up in the cloud and not give hackers from Mars access to our Active Directory. And he's like, what do you mean it's going to take 6 months? So the hard part is going to be finding the right balance between hack it together for a proof of concept and hacking it together in a way that you can reuse the work you did for that proof of concept and actually build it into the actual hardened Legos you need to snap together to make your application. I've been doing this for 20 years and I always err on the side of more formal structure, careful componentization, and making absolutely certain that I at least have this concept of this public idiom, contracts, aka public idiom, aka public contracts, aka DTOs and interfaces. Dependence, direct dependencies. Yeah, okay. And yeah, that's my rant. That's my sermon. And it's more than just astronaut architecture. it's more than just a sermon. You can actually look at these concepts in action on my GitHub. And I'll post well, you can get to my GitHub through my link tree. Let's see here. Where is my dashboard? Twitch. I need to look up the URL to my link tree. Here we are. I'm going to open this up real quick. See my Nightbot commands, project repo stack Y. Okay, that doesn't really help me. Not song requests or anything like that. I don't have. 9 of 12 posted my link tree in the chat the other day, but I don't know how she did it. Linktree is somewhere outside the video window here, and you can get to it. And that will take you to my GitHub and all of that other wonderful stuff. And yeah, so that concludes our discussion of the code level, the project level architecture. Now, I do have some stuff about the way I've architected the user interface. And I think I'm going to I'm going to use these in the documentation that I'll post to my GitHub. And I think I'm probably going to turn this into an actual written article that I'll put on that developerdad.com at some point before too much more time has gone by. It's a matter of cranking out the article and organizing my thoughts and so on. But yeah, the UI architecture, it's a layered architecture, but rather than layered like a cake, it's layered more like an onion or Russian nesting dolls, where you've got the app host on the outside. It contains things like your header, your main nav. At the code level, it would contain application state. So login or authentication, current user information, stuff like that. And then you've got a feature host, which when you hit a nav link, it will load a page into the feature host area of the screen. And then the feature, of course, has a number of tasks that can be done on whatever conceptual thing or process is described by the feature. And I get into some details about how the different screen elements are laid out at the app host and the feature host, and finally the task host layer. And yeah, I think I definitely need to turn this into an article, because this is how I've laid out the Blazor app. And we can actually see it in action. That's not the Blazor app. That's that's SQL Server Management Studio. But we can run this guy. And I can show you as it's spinning up. I'll come down to the UI. Oops. Now we're in Git change land. It's bouncing around. So we've got here, we're on the home page, or the home feature. We'll go into the NPC feature. And the way I've got all this laid out, we can even simulate a mobile mode. And the way I've got this laid out, and this took me probably 4-ish streaming days to get right, because I am not strong in the UI. So a Blazor application, everything goes into a main layout.razor file. And you can see here, div class app host wraps a header and a main element, just like I say here. We've got the app host header, app host main, And that main is decorated with the feature host CSS class. And then at body is what gets loaded when you click an item over in nav menu. So if we come down to our pages, I can go to create NPC, and we're only showing the feature header when we're not on the list view. And when we are on the list view, we hide this thing because it's got just sort of the manage NPCs and the button that takes us back to the list. And then the main area contains our components, and the components are create NPC razor page. Also, we have a footer, but it's currently hidden. There's nothing in there because I don't want to put any feature level navigation at the bottom of the screen, thinking about the way I use my phone. And just for example, we'll go into the NPC list component. And I've got a folder in here called partials. And we'll open up NPC list razor. And we see that right up here at the top, the parent element is a task host. And we've got our task host header, which may or may not have some navigational elements in it. And then we've got the main, which is where the actual worker code for our task goes. And then finally, if we had any kind of footer stuff like action buttons that are pertinent to the NPC list, we would put those down here. Now, the reason I put the create button up here in the list, up at the top of the screen, is because if we're using our phone, or if we're using this in our phone and we're scrolling up and down, I don't want my thumb to accidentally hit that create button and take me away from this view. I need navigation away from this view to be very mindful. So I've kind of hidden it up here, nice and demure. And of course, we come in here, we'll eventually be able to do edit. And then from the edit view, I'll go save. There's some more work to do here in the UI. But we can just nav back to the list. And I don't want to have back to list down here where my thumb might bump it by accident. But you can see here, this would be the task header. And I do need to do some styling in here. And this guy down here lives in our task footer. So we can go back to our list, pick another one, back to the list, and yeah. And so when I add new components or new partials, new tasks to the manage NPC area, I'll just add new partials in here, and I'll build them inside this structure. And if I need to, I can even come in here and specify, like let's say I want to make the just on the NPC list. Actually, no, that's a bad example. Let's say on the view NPC details, these guys have CS. This guy has not got a CSS file. I could add one and override the way the header gets painted right in here, and it'll only apply when this component is being shown. So yeah, there's a lot of power in this model, and it's going to really help me move a lot faster as I go. There's some code level architecture that we have going as well. For instance, our page, if we view the code, I'm doing that a little bit differently. I'm using page models for that. The page owns an event notifier, or owns an instance of page event sync, and can pass that event sync into its child components. And then when the child components do something that the other components need to know about, they can raise an event into that NPC event notifier, and the other components would register to, yes, I care about this event, I handle it like this. So when component C raises event A and component A cares about event A, component A will get a copy of that event, take action, and then we'll be able to coordinate the work between all of the different partials without actually tying the partials together. And I know I'm going to need something like that at the app model level. I'm just not sure how to do that yet. I don't want to create a singleton service, but I might not be able to get away with it because we are going to have some things that need to exist at the main layout level. And I'm not absolutely certain how we're going to manage those yet, because I've been working with Blazor for about 2 or 3 weeks at this point, and I tend to just learn enough to execute what I need to execute when I need it. So yeah, and that is sort of our quick tour through how this application is built out. And just sort of a spoiler alert, every application I've created in the past probably 5 or 6 years looks extremely similar to this concept. And I've been using these kinds of ideas for probably the past 5 or 6 years since I first learned about this way of approaching what code goes where. And with that, I will say good afternoon. I'm Rob. I'm that developer dad. And take care of yourselves. If you want to see the past streams where I've built all of this nonsense out, you can find it on my YouTube and subscribe over there and so on and so forth. So be good to yourselves. Have a great rest of your day.